I'm here to share a little bit about how we use KWOK to help us prepare for scale as we manage our large fleet of data centers. So if I had 30 seconds to leave you with something to take away from this talk, it would be what is KWOK and why is it that you might find that interesting. So KWOK is basically a tool you can use to simulate a large number of nodes or pods on a very minimal resource requirement. So you could use a single laptop or a very small Kubernetes cluster. Now, why KWOK? So if you manage control plane services whose behavior would probably be affected by the number of nodes in the cluster or the state of those nodes, then KWOK might be a great toolkit for you to play around with scale. So now that I've set that up and you know what KWOK and why you would need it, I'd like to share a little bit about how we used it, and it might even extrapolate a use case you might have. So firstly, I'd like to get started giving you a background about our scale. So we have about 80 data centers worldwide, which are production clusters, and we deploy about 50 microservices per data center. So the resource crunch is pretty heavy for us. So now, so looking at the scale of the clusters themselves, so typically our dev environments have about 50 nodes, and our production are about 800 nodes. I think our largest one is 1250 nodes. And the workload, if you look at that, we have about 1,500 pods running on our dev environments and about 18,000 pods running on our production clusters. So the scale difference between our dev and prod are pretty huge. So anytime we develop or implement something new, we test it against our dev clusters, of course. But we have to make sure that it can work at the scale of our production environments. So something that we have to keep in mind is to always build for scale. And this is something I'll keep referring back to. So now let's get into the specifics of this use case I've been talking about. So we deploy most of our services using Helm charts, and many of our services have daemon sets. So the default deployment behavior for a daemon set, if you don't have any specific tolerations defined, is that it will try to launch one pod of your daemon set on every node that matches your criteria. So any nodes that are not ready, it will automatically skip it from rollout. But we had a special case where some of our daemon sets defined a specific toleration which said, I want to tolerate all taints. This meant that it would also try to launch the nodes, pods on nodes which are not ready. So the pods get stuck pending forever. This caused our daemon set rollout to fail, which marked our Helm deployments as failure. But our criteria, we wanted to deploy it on all nodes possible, but skip the nodes that are not ready. So how did we handle that? So as any automation-driven team would do, we first wrote a script. So in our first iteration, our script would basically get the list of nodes, check how many of that match the deployment criteria, and if the pods are coming up OK on those, it will mark the rollout as success. So we were happy with that. We started rolling this out across the fleet. Now, this worked well on some of our initial clusters, but as we started hitting our larger production environments, we started running into out-of-memory issues. So we realized we hadn't built this for scale. So how can we go about making improvements to our script, but be able to test it for scale without having to hit our large production environments? So this is where KWOK came into picture and really helped us. So if you look at this flow here, so first, we will make changes to our script, any improvements that we want to make. We can go ahead and execute it on our current dev clusters, verify that the functionality is still working as expected. Now, to test for scale, we were able to use KWOK and launch 1,000 nodes, 1,500 nodes, and run the test hook again. Now, if it worked here, we were sure that it was ready for scale. So we could continuously iterate over our script and test it for both functionality and scale because of the help of KWOK. So using KWOK, we were able to simulate more than 2,000 nodes, which is already bigger than our current max scale. And using that, we were able to make all of these improvements to our script. So we were able to implement caching, because of which we were able to reduce the amount of queries we were making by 40%. We could batch the API calls that we were making to list the nodes. And we also were able to reduce the amount of data that we stored in memory about the node. So using KWOK, we were able to achieve our goal, which was to always build for scale. So I hope that has piqued your curiosity about KWOK. Some of my colleagues are also having some talks about some additional use cases where we have used KWOK. So I'd encourage you to check them out as well. That's all I have. Thank you.